Chapter 5. We are breaking up into different parts. So today's just part 1. We'll probably end up doing 3 parts, I believe.
So we can get homework after we finish.
No, we're getting homework over each section.
Right.
So, we'll be good.
Yeah.
So graphing radical functions, part 1. And change. There we go. So, just a little overview. A radical function contains a radical expression. Go figure. With the independent variable, what's my independent variable? X or Y? X with my independent variable in the radicand. So radical expression has a radical with X under the radical. When the radical is a square root, the function is called a square root function. That's pretty hard to remember, isn't it? When the radical is a cube root, the function is called a cube root function. Even harder to remember.
How are we supposed to remember that?
I don't know, Chris. How are you supposed to remember it?
I'm not sure. I thought
I
you
don't
would
know.
know.
I know. Well, maybe we'll find a way. But that's just a brief overview of what a radical function is. Square root function, cube root function, so on and so forth. Can I move on? So we're talking about graphing. So back in the past, we've talked about graphing a few times throughout the semester, throughout the year actually. Each time we've talked about graphs, we've talked about parent functions, correct? Remember, a parent function is just the most basic form of that family of functions. So, my square root function has a parent function. My cube root has a parent function as well. So I'd make sure that I would know what the parent function is for a square root, as well as for a cube root. And you may want to have the graph of each of them kind of sketched on your paper. And you may want to go ahead and write down the domain and range of each of them.
Can we just draw those out?
Maybe just a rough sketch. So the parent function for the family of square root functions is f of x equals the square root of x. The parent function for the family of cube root functions is f of x equals the cube root of x. Let me ask you a question. If we're just dealing with real numbers, not imaginary numbers, just real numbers, am I able to take the square root of a negative number?
No.
No, I'm not able to. I'm not able to take any even root of a negative number, am I? So that's why this graph looks the way that it does for my square root function. If you notice, the domain is x is greater than or equal to 0. Because if I plug anything in that's less than 0, that's going to be a negative number. I can't do that when I'm talking about real numbers. So I can plug in any number that's from 0 all the way to infinity. That's why my domain is x is greater than or equal to 0. And then that makes my range y is greater than or equal to 0. Because my stopping point is 0 and it goes all the way to infinity. So there's the domain and range of my square root function. Can I take the cube root of a negative number? I can, right? What's the cube root of negative 8? Not 2. Negative 2. It's just negative 2. Negative 2 is the only thing that when I multiply it by itself, times itself, I get negative 8. Negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8. So the point there is that I can take the cube root of a negative number. I can take any odd root of a negative number. Third root, fifth root, seventh root, so on and so forth. So, this graph actually dips down into the negatives because I can plug in negative numbers. Domain and range are just all real numbers. There's no stopping point left or right, or up or down. It hits all my real numbers. Any questions about any of the information on my parent functions? You know what comes along with parent functions? Starts with a T. Transformations. We will have transformations as well. Yay. Can I go ahead and move on?
No, not really.
Okay, I'm waiting. Graph each function. Identify the domain and range of each function. Letter A. I have f of x equals the square root of 1/4 x. Wants me to graph this function, state the domain and range. The way I'm going to graph it, I'm just going to create a table of values. What might be pretty good to plug in here to get rid of that fraction? Multiples of what? 4. If I multiply this fraction by multiples of 4, it's going to get rid of the fraction. So I'm going to make a little table. Bless you. First number I'm going to plug in is 0. 0 is always a good number. What's 1/4 times 0? 0. Square root of 0. 0. Everyone good with that? What's the first multiple of 4? Not 1. 4. What is 1/4 times 4? 1. Square root of 1? 1. Everyone good with that? What's the next multiple of 4? 8. What's 1/4 times 8? 2. Now I've got to take the square root of 2. Handy dandy calculator. I get 1.41. What's the next multiple of 4? Not 16.
12.
12. 1/4 times 12. 3. Type in the square root of 3. Not 3. 1.73. Everyone okay with where I'm getting these numbers from? So now I can just graph these ordered pairs. 0, 0. 4, 1. 8, 1.41. 12, 1.73. At least somewhere in here. Now I can connect my points with a nice smooth curve. And there's my graph of f of x. Any questions there?
What are we doing?
We're taking notes. Oh, sorry. Questions on how I got my graph? We just plugged in values, got y values to give me an ordered pair. Now it wants the domain and range. Can someone raise your hand and give me the domain of my function here? X is greater than or equal to 0. Very good. Because it does not go to the left forever and ever, does it? It's got a stopping point. What's the stopping point? 0. So it's going from 0 all the way to positive infinity. So that's all the numbers that are bigger than 0, correct? So that's why it's x is greater than or equal to 0. Questions on the domain? Raise your hand so you give me my range. Not quite. I agree with the y is greater than or equal to. Is it going to go up forever and ever and ever? Yep, it's gradually going up. It's just going to keep going up and up and up and up and up. Is it going to go down forever and ever and ever? What's my stopping point going down? 0. So y is greater than or equal to 0. It's all the y values that are greater than or equal to 0.
Is it always going to be that with square roots?
No.
Okay.
We'll see an
Because that's
example
what
here
it
in a
is in the
second.
example,
Right.
or in the thing.
We'll see an example here in a second where it's not
Okay.
this. Okay? Questions on A? Not too bad. Can I erase and move to B? Take that as a yes. B. G of x equals negative 3 times the cube root of x. G of x equals negative 3 times the cube root of x. So on letter A, I wasn't able to plug in any negatives, was I? Because it was a square root. Can I plug in negatives on this one? I can take the cube root of negatives. So once again, I'm creating an XY table. Now let's just use negative 2, negative 1, 0, 1, and 2. Some negative numbers, some positive numbers, 0. This will be pretty good. Plug in negative 2. So with the cube root, negative 2 times negative 3, which gives me 3.78. Just typing it in your calculator. What's the cube root of negative 1? Negative 1. What's negative 1 times negative 3? Positive 3. What do I get when I plug in 0? Any questions so far? What's the cube root of 1? 1. 1 times negative 3? Negative 3. What do you think I'm going to get for plugging 2 in? Negative 3.78. Questions on those values? Okay, let's graph them. Negative 2, 3.78. I'll be up here. Negative 1, 3. 0, 0. 1, negative 3. 2, negative 3.78. Connect my points. There's my graph of g of x. Questions how I'm getting that? Okay, now it wants me to describe my domain and range. My domain is all real numbers. There's no stopping point going to the left. It's going on forever and ever and ever. There's no stopping point to the right. It's going on forever and ever and ever, correct? What about my range? That's also all real numbers. Because while it's going to the left, it's still going up. So it's going to go up forever and ever and ever. As it's going to the right, it's going down. It's going to go down forever and ever and ever. So there's no stopping point up or down either. Any questions on my domain and range here? Not too bad? Moving on. Transformations, told y'all they were coming. There we go. So if you notice in example 1, the graph of f was a horizontal stretch of the graph of the parent square root function. The graph of g was a vertical stretch and a reflection in the x-axis of the graph of the parent cube root function. So like we said, you can transform graphs of radical functions in the same way you transformed graphs of functions previously. So you know all those little formulas we've used before? We're going to use them again. We've seen these formulas a few times this year, correct? They still apply to cube root functions, square root functions, so on and so forth. So we're going to use them again. You have these somewhere in your notes. This is also in your book, once again, in this section. So you'll want to know where it is or have it written down at some point so you can access it, especially if we have a quiz over any of this stuff. But here are my transformation formulas. We're ready to jump into an example of transformations? Yeah, if you need to take a picture of that, go ahead. That's fine. On that horizontal translation, this is a minus sign right there. There you go. Like I said, you have this in your notes somewhere. It is also in your book in section or chapter 5, section 3.
I'm gonna wait for my phone to turn back on. It takes forever.
Example 2.
Oh.
Did you get it up?
Yeah,
Good. Okay. Example 2. It says, describe the transformation of f represented by g, then graph each function. So my f of x function is just my parent square root function, correct? And so it wants me to describe the transformations that's occurring from here to here, and then graph the function. So I've got x being subtracted by 3 underneath the radical. I've got 4 being added to the function outside the radical. So let's look at our formulas and see if we can see which transformations are occurring here. Can anyone give me one of my transformations? Horizontal translation. How many units and which way? 3 to the right. Very good. We have x minus 3. So I'm subtracting underneath the radical. And so that lines up with this formula right here. As you can see, there's an example similar to it. It's x minus 2 here, so that's 2 units to the right. We have x minus 3, so I know it's 3 units to the right. Remember, if it's under a radical or inside grouping symbols, we'll do the opposite of what the sign would usually tell us to do. So since it's minus 3, we're going right 3. So there's one of my transformations. And then I have that plus 4 outside of the radical. So like we said, it's a vertical translation, 4 units up. If it's outside grouping symbols or a radical, we follow what the sign tells us to do. So since it's plus 4, we're going 4 units up. So I could say G is a horizontal translation. Three units right. Followed by a vertical translation. Four units up of the graph of f. So of f. So this would be my description of the transformation that's being represented by G. Does everyone see that? You have to have every transformation within your description. You can't just do one of them, you got to do all of them. Any questions on my description on letter A? Then it tells me to graph it. So let's graph our parent function real quick. Square root of 0. Plugging 0 in right here. What's the square root of 0? Square root of 1. 1. What do we say the square root of 2 was? 1.41. Square root of 3. 1.73. Square root of 4. 2. So 0, 0. 1, 1. 2. 1.41. 3, 1.73, 4, 2. There's my parent function, correct? Now there's two ways I could graph my other function. I could create a table of values, just like I did for my parent function. Does anyone have any other ideas on how I could graph it that would be a little easier? This is just two translations. So am I changing the shape of the graph at all or the orientation? No, I'm literally just changing the position. So I can just take all my points and do the translations that are occurring. So what translations are occurring again? 3 units right, 4 units up. So I can just take each ordered pair and go right 3, up 4, put a new ordered pair, and that'll be the correct transformation. So 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. So here's the graph of g of x. Does everyone see that? Since it was just the translations, I just took each point, translated them, however many units I needed to. What's the domain and range of my parent function again? X is greater than or equal to 0. Y is greater than or equal to 0. What's my domain of my g of x now? What about 3? Here, my domain is x is greater than or equal to 3. There it is, Mallory. What happens if I plug in a number that's less than 3? Let's say I plug in positive 2. What happens when I plug in 2 here? What's 2 minus 3? Negative 1. I can't have a negative under the radical. So any number I plug in that's less than 3 is going to give me a negative under the radical, which is why my domain is x is greater than or equal to 3. Does that make sense? Because I can plug in 3 all day long. I can plug in any number that's greater than 3 all day long. Because those are going to give me 0 or positive numbers under the radical. But once I get lower than 3, I'm going to get negatives, which I don't want. What about my range? What's my range of g of x?
Y is greater than or equal to 4.
Very good. My stopping point here is 4. So y is greater than or equal to 4. So it's all values that are greater than 4. Questions on This example right here. Not too terrible? Do you have a question? Okay. Can I erase and move to B? To be or not to be? That was funny. Y'all don't like my humor, do you? My humor? You like it? Why didn't you laugh at the joke? Ha! That was good. I like that. Letter B. We have our cube root parent function, cube root of x. And then we have g of x equals the cube root of negative 8x.
Do we have to write the first part down?
What do you mean? The f of x?
Yeah, we need to write that.
You may want to write it down. I always like to have the parent function there to compare it to. So, it wants us to describe the transformation of f represented by g first, and then to graph it. So I've got g of x equals the cube root of negative 8x. I do have two transformations here. I have some sort of stretch or shrink, and I do have some sort of reflection. I just got to figure out which one of each of them it is. My negative's on the inside of the radical. So is that going to be reflection over my y-axis or x-axis?
Why?
My y, because it's inside grouping symbols. Right? So I know it's going to be a reflection over the y-axis. What about my stretch or shrink? Is it a stretch? Is it a shrink? Is it horizontal? Is it vertical?
It's a horizontal shrink.
Horizontal shrink by a factor of what? 1/8. Very good. Remember, when we have horizontal stretches and shrinks, it's by a factor of 1 over a. So here, the a value is 3, so it's by a factor of 1 over 3. Here, the a is 1/2, so 1 over 1/2 would give me 2. So here it's by a factor of, here's my a value, 1 over 8. So it's a horizontal shrink by a factor of 1/8. So I'd say g is a horizontal shrink by a factor of 1 over 8, followed by a reflection over the y-axis of the graph of f. Any questions on the description of my transformations? Not too bad. Now we need to graph it.
We go back for just a second.
Yep.
What did the first one say after the four units?
The first one was G is a horizontal translation, 3 units, right? Followed by a vertical translation, 4 units up. 4 units up of the graph of f. I just say of f. Questions on either of these transformations? Are we a little more comfortable using the formulas and identifying the transformations now that this is our third time around of doing it? A little more comfortable than the first time?
Yes.
Hopefully. Can I move to my graph? All right, let's graph our parent function first. Let's just go -2, -1, 0, 1, 2. I've got the cube root negative 2,
3.7. Oh, wait, no.
negative 1.26. What's the cube root of negative 1?
Or negative one.
Negative 1. Cube root of 0. Cube root of 1. 1. Cube root of 2. There we go. 1.26 goes under 2. So negative 2, negative 1.26, negative 1, negative 1, 0, 0, 1, 1, 2, 1.26. There's the graph of my parent function. Now I need to graph g of x. I'm going to plug in the same values. So plugging in negative 2, what's negative 8 times negative 2? Positive 16. So I'm taking the cube root of positive 16. Gives me 2.52. Plugging in negative 1. What's negative 8 times negative 1?
8.
8. What's the cube root of 8? 2. What do I get when I plug 0 in? 0. Negative 8 times 1? Negative 8. Cube root of negative 8? Negative 2. And when I plug 2 in, I get negative 2.52. So negative 2, 2.52. Oh my goodness. Negative 1, comma 2. 0, 0. 1, negative 2. 2, negative 2.52. There's the graph of g of x. So, what kind of stretch or shrink did we say it was? Horizontal shrink. So it's shrinking horizontally towards the y-axis. So that means it's squeezing, it's coming together and getting wider. And then what else did we say it was? A reflection over the y-axis. So it got shrunk and it reflected over my y-axis. Does everyone see that for B, part B on example 2? Any questions about the notes? Can I move on?
What time did we get out of here again?
150. Can I move on? Here we go. Page 260, 2 through 28 evens. This will be due on Tuesday, April 20th on Canvas. You will need graph paper. I'll pass out the graph paper for you guys. Are there any questions before I end my recording about the notes?